Yeah. Okay. So angles. First of all, what makes an angle acute?
Less than 90 degrees.
Okay, Joey? What makes it acute? Less than 90. I'm going to add on something here. I'm going to add in a new symbol for you guys to get freaked out about. It's not just less than 90 because if it was 0, that's a whole other angle. So it's between 0, so it has to be greater than 0, but less than 90. And the symbol I'm going to add up here is a Greek symbol, theta.
What's it called?
Theta. T-H-E, theta. T-H-E-T-A, theta. And you guys don't freak out about it. It's just like any other variables, like x's and y's. It's just a variable, but we use theta to represent angles. Okay. So it's just a symbol. It's not freaking out
So
because
that
it's Greek.
just all stands for is less than 90.
Yep. So just the variable is less than 90. It's just a variable. All right. So Austin, you want to go up here and draw this?
Yes.
You know how to use this?
Oh, you're gonna make sure. You're gonna make the kid that can barely draw it. Angle on his paper.
Okay. So Austin's going to attempt to draw this. Those of you guys viewing at home, play him.
Yeah, it is good.
Where are you drawing? Draw underneath that.
No.
Hover. There you go.
Press
Click.
down.
Press down. Hey, there's one.
You erase.
Look at the eraser button.
Oh,
What are you
erase.
doing?
What? This is too hard. Drawing the eraser button.
Now the people at home can't see that. Hold on. You're in the way. All right, so stay here. Don't draw yet. There you go. All right, so Austin says this is what an acute angle would look like. So, and then yes, and this is the thing I want to make note of. A lot of times we notate our angles, they have this little arc that's inside them. Okay, so that just means angle. All right. Who can tell me what a right angle is?
Oh, it's exactly 90 degrees.
Casey?
There's an angle that lies right on 90 degrees.
Exactly 90 degrees.
Yeah, you should definitely do that.
All right, so go ahead, Austin, attempt to do a right angle. So you're right. And we notate right angles because it has a box in the corner. And that's probably a really bad box. So let's erase that and start over. So there's our right angle. Okay. What about obtuse angles? Zane? Has to be above 90, so like 290?
91 to 179.
91, 179. What about 179 and a half?
Yeah, I guess.
So just
Okay.
above
So what are the limitations?
180 and
It can't be so it has to be between 180 and 90, but not include those. Okay. So we say between 90 and 180 exclusively. That's how you would say that statement to get it better. Or we can just go right back over here with the compound inequality. We have to be greater than 90. There's theta, but less than 180.
Austin.
Okay. Go ahead, Austin. There we go. And we'll throw a little angle measure in there. What about a straight angle?
It's actually 90.
Straight line. But do I still have a vertex with a straight angle?
Yeah.
Yeah. So here's my straight angle. I still have a vertex somewhere in there. But on that now the straight angles can actually have two angle measures. What are they?
180.
Either 180 degrees, or they could be
360.
0 degrees. Or in this lesson, I'm going to get to that so much later in the semester. But yes, 360 is also the same thing. All right. Any questions on those? Okay, this is like elementary review here. Any questions so far?
Yeah. He needs anything.
Okay, so let's get to new terms. And these aren't new terms, but for some of you, they might feel like they're new. Complementary versus supplementary. Dylan, okay? Think back to your free lesson you had to do yesterday. What is complementary? Go ahead, Dylan.
When both angles add up to 180.
No.
Or is that, no, it'd be when either or two angles add up to 90.
There we go. So it's not when either, but it's when two or more. Okay? Basically, if two angles are complementary, they add up to 90. So what does that actually create then? A right angle, so therefore we can easily draw that as a right angle. So here's my right angle, and I'm going to throw in, and then let's label those. So let's call that A, B, C, and D. And now we can actually write an equation. We can say that the measure of angle ABC,
Wait, so these not gonna have arrows on them?
you don't have to, plus the measure of angle CBD is 90 degrees. That's what it means to be complementary, to measure the angles. Now, guys, we talked about this the day before. What are my variables up there? How many variables do I have in that equation?
4.
No.
Two angles.
So how many variables do I have? Dakota? 5. Nope. Train your brain differently. Not 3.
Wait, how many angles?
How many variables do I have in this equation? Austin? 2. What are those? What are my 2 variables here? Nope. What are my 2 variables? Dakota?
Angle ABC.
Yeah, the measure of angle ABC is one variable, and the measure of CBD is the other variable. Guys, you got to train your brain differently. Just because we see letters doesn't mean they are variables. We have to see them. In geometry, your variables are the objects. Angle ABC is our object. That's the variable. CBD is the object. That's the variable. Okay? So again, just training your brain differently. All right, so let's keep going on here. This time, let's talk to someone we haven't heard from yet today. Let's go to. Oh, Taylor's sleeping. Leave him alone. Shannon, what is a supplementary angle? You don't know. The one time I need you to follow through. Jeez. It's all right. All right, we'll come back to you. We'll have another chance to. Keisha, what about you? Adds up to 180. So what would that look like then? What type of angle does that create? What do we call that on the slide? Straight angle. Okay, again, I know you guys are used to using generic language. We want to make sure we're using specific language. So we straight angle. And a lot of times with this, we have a vertex somewhere in there. Doesn't really matter where. And then we have a second line. It goes jutting out. And again, let's label that. So we have points A, B, C, D. So what are my 2 angles now? Angle ABC and CBD. So this time, the measure, notice how I say the measure, I represent the lowercase m. The measure of angle ABC plus the measure CBD is 180. Any questions on that? A lot of vocab this morning, I get that. But it's not, too much for you guys to get down. A lot of this you guys have seen before. So So now let's get into the actual new stuff that I think a lot of you guys are not used to. Okay, so here comes some new definitions. And this time we're going to use our brains. I want you guys to think logically. I know it's hard. But for a lot of you, you made a purpose in life to not think logically. But I need you to try that in this class.
I guess what an adjacent angle is.
Sure.
Just to see if I remember. An adjacent angle is where you're gonna have like a 90 and go like this. It's both sides go like that.
No.
It's not.
No.
It's not.
Casey.
I'm wrong. I don't know what I'm doing.
Could be. Let's do this. What does it mean to be adjacent? No, that's zero. What is adjacent? Beside?
Like right beside.
Yeah, right beside, next to, right? I know out in the Southwest when they build housing developments, like take Baltimore Place. You guys, if you notice the homes in Baltimore Place, they're really close together, but there's not really a lot of fencing in between the homes. And in the Southwest, when they build homes like that, it's very small lots. They put this brick wall right between the two lots. So you have this shared wall. So, and kind of what that looks like is you have, here's your back wall that's in the backyard, and then you have a whole series of homes that are split up by brick walls. The worst sign I've ever seen, which I can't believe they advertised this. 27 acres for over 100 new homes. Sign up quickly. Like, yeah, 27 acres and 100 homes. Think about that. Houses, no. Houses were small. They were, basically 13 to 2,000 square feet, so they weren't exactly super small. But the lots were. So basically that's what they look like. So when I think about adjacent angles, I always think about this brick wall going between the two homes. The two homes share that wall. Okay, so if you are an adjacent angle, what that looks like is you have a normal angle, but then the two angles actually share a side. Okay, so by definition, adjacent angles, they share two things. They share a vertex. So notice that this angle and this angle, they're sharing the vertex, and they also share a side. Okay, so that's what makes it an adjacent angle. They have to share a side and a vertex, and they have to be connected.
But I went like this, and they connected.
All right, guys, next thing I want you to think about, linear pair. Linear implying what? Linear pair. What is linear? When you think of linear, what word does that imply? Go ahead. And this is the whole purpose of you guys doing that activity last night that I don't think a lot of you guys did. Okay. So what is linear pair? Oh, guys. Oh, Mariah, yes.
Can I shoot out the definition?
Sure, works for me.
Linear pair is the two supplementary adjacent angles formed by two intersecting lines.
Holy cow. Wow.
Yeah, that's fine.
So what does that mean?
Okay, let's simplify that. Linear means we make a line, and a pair means that we have two things. So it's two angles that form a line. It's a linear pair.
You mean two lines that form an
No.
angle?
I don't really, I don't know by all practicality, this is a second line. I always think of it as two angles. So you got this angle on the left, the obtuse angle on the right. The two angles, they make a line when you put them together. Okay, so that's a linear pair. All right, guys, you need a big star next to vertical angles. We are going to be referring to this term a lot, almost every day in this class throughout the rest of the semester. This is a huge term to get down. Remember we do tick marks for segments?
So that would just angle one, angle two.
And they're different measures. If they're the same measures, they'll have the same number of lines. Linear pair, two angles that form a line. All right, so vertical angles. Here we go. Look for the X. Anytime that you have two lines that intersect, you will have vertical angles. Anytime, no matter how you draw the lines, you have two lines that intersect, they will form vertical angles. And there's something very special with these vertical angles. The vertical angles are basically opposite of one another. So those two right there are the vertical angles. And very, very important, I cannot stress this enough, vertical angles are always, what is that symbol? Congruent. Okay? Vertical angles always have the same measure. Always. Okay, so Taylor, anytime you have two lines intersect and they make an X, always look for the X. And those two angles are always going to be equal. Well, what about my angles here on the left and right? They would also be considered vertical angles. So these two are equal. No, it's the green right here. Yeah. That's going all the way. That's an arc. Okay. And Mariah brought up a good point. Looking back over here to this diagram, notice that we have the red arc here. We have the two green arcs. Okay, this basically works very similar to when we do tick marks for lengths. If you have two lengths and they each have one tick mark on them, what does it tell you about the lengths? They're both the same. But if I have one tick mark on this length and two on this length, they're different. The way we do that with angles is we do it with arcs. So this arc is just one. This one has two, so therefore they're different lengths. They're different measures. I know. And perpendicular, meaning what?
That they're parent. Don't answer.
What is perpendicular? The cross, but how?
If that one wasn't in our book.
Like a plus or a T.
Yeah, like a plus or a T. Perpendicular lines intersect at right angles. Hey, do you guys have, do we get vertical angles with perpendicular lines?
That's your favorite.
Yeah. Now down here, I also have another right angle. Okay, so we still have vertical angles.
So what's the definition?
What?
The definition?
They intersect at right angles. Alright, let's get into some heavy duty stuff now.
Yeah. Oh.
Oh, I like that.
We're gonna practice. Alright, we did a whole bunch of definitions. A whole bunch of definitions. Let's actually get into doing this stuff.
Oh.